Voyager 2 has long been humanity's most distant messenger, faithfully beaming back the secrets of the void. Yet now, it has delivered its most unsettling revelation, a discovery so baffling and alarming that it has sent shock waves through the scientific community and beyond. It began unassumingly, as these things often do. The initial signals were barely distinguishable from background noise, just faint blips buried in the endless stream of data Voyager 2 has sent since crossing the heliopause in 2018. 4 years, its transmissions were steady and predictable, measuring the thin plasma and magnetic fields of interstellar space. But then, patterns began to emerge, subtle at first, then impossible to ignore. A sequence of high-energy particle readings so anomalous in intensity and rhythm that even seasoned mission scientists felt a chill run down their spines. Instruments carefully calibrated over decades began registering bursts of radiation with signatures unlike anything recorded before. Bursts that persisted and grew stronger with each passing transmission window, as if carrying within them a cosmic message of unimaginable scale and consequence. At first, the team dismissed the data as a sensor glitch. Voyager 2 is more than 4 decades old, its systems prone to failure and noise. Engineers of the telemetry center combed through logs, compared redundant data streams, initiated diagnostics, rerouted power through backup circuits, and adjusted the high-gain antenna to rule out interference from Earth or the Sun. Every possible technical cause was systematically eliminated. And yet, the readings persisted. Sharp spikes of charged particles with energy signatures that seemed to suggest both a nearby and impossibly distant origin at once. It was as if something out there had awakened, revealing itself only now, far beyond the protective bubble of the solar wind. As the realization set in that the phenomenon was real, discussion spread beyond the engineering teams to planetary scientists and astrophysicists. Experts pointed out that the intensity of these particles dwarfed anything Voyager 2 had measured near Neptune or even in the chaotic transition at the heliopause. Their spectral distribution hinted at processes far more violent than typical solar flares or supernova remnants. It appeared that Voyager 2 had stumbled upon a phenomenon that defied current models of interstellar physics, something the universe had kept hidden until now. The implications were staggering. If Voyager 2, drifting more than 18 billion kilometers from Earth, was detecting such raw power, then the source must dwarf any known cosmic accelerator. The idea that a new, previously unknown type of galactic engine existed, capable of hurling particles across light years with such ferocity sent ripples of both excitement and fear through the scientific world. Astronomers scrambled to point ground-based observatories toward the spacecraft's line of sight. While space-based telescopes were reprogrammed in hopes of capturing a visual counterpart to this invisible storm, all eyes turned toward an unseen threat growing in the cosmic void. Yet amid the scientific enthusiasm lay a darker, more unsettling possibility. The readings carried a peculiar structure, an almost rhythmic modulation interwoven with chaotic spikes suggesting intelligence or design. The oscillations were intricate, not random, as if the very fabric of space-time were being twisted and shaped by an unseen hand. Was it a natural phenomenon so strange it mimicked intelligence? Or was there truly something conscious behind it? The possibility that Voyager 2 had tapped into a cosmic beacon broadcasting with malevolent purpose was enough to fill even the most rational researchers with dread. Theories proliferated at a dizzying pace. Some speculated that Voyager 2 had crossed the path of a dormant interstellar object, perhaps a relic of an ancient civilization finally awakening after eons of silence. Others floated more terrifying hypotheses. A collapsing star on the brink of forming a black hole with unprecedented violence, its singularity ringing space-time with quantum effects that spread outward in unpredictable patterns. If such a cataclysmic event was underway, would the resulting wave of high-energy particles eventually wash over our solar system? Would Earth's magnetic field withstand such an onslaught? Or would our planet's fragile shield buckle under cosmic hammer blow? Philosophers and theologians joined the debate, pondering the significance of humanity's tiny emissary encountering such cosmic fury. What did it say about our place in a universe if Voyager 2, launched with dreams of peaceful exploration, had become the unwitting herald of a revelation too large, too alien for human comprehension? Some saw it as an invitation to a new era of understanding, a forcing function to confront the limits of knowledge and courage. Others whispered about existential threats, warning that intelligent life must tread carefully lest it awaken forces beyond control. Back on Earth, mission controllers faced a dilemma of unprecedented gravity. Voyager 2's trajectory could not be altered, and its aging instruments would keep recording every surge of particles until power failures silenced them forever. NASA reallocated data budgets, deprioritizing other deep space missions to ensure every last byte from Voyager 2 was captured. Scientists worked through the night, decoding the incoming streams, charting every spike and fluctuation as if piecing together a puzzle whose final image might reveal the fate of entire worlds. The mystery deepened when researchers asked, why now? Voyager 2 had been in interstellar space for years without encountering anything remotely like this. Then at a distance exceeding 124 astronomical units, it suddenly stumbled into something that turned the quiet interstellar medium into a cauldron of raw energy. Was it simply drifting into a denser region of exotic plasma? Or had something dynamic and violent stirred the cosmic soup? Some suspected an interstellar shock front, the lingering aftermath of a long-ago supernova, might be sweeping through our part of the galaxy. Radio telescopes scanned for complementary signals, detecting only faint whispers compared to the maelstrom Voyager 2 recorded. Particle detectors aboard the International Space Station and lunar orbiters saw no correlated bursts, their readings consistent with normal solar cycle variations. It was as if the event was unique to Voyager 2's path, an accidental rendezvous with a cosmic phenomenon no other probe was privileged or cursed to witness. As news of the mystery spread, the public caught wind of the strange, unsettling developments. Headlines warned of cosmic threats. Talk shows speculated about alien contact or impending doom. Social media exploded with theories ranging from government cover-ups to utopian dreams of first contact. Conspiracy theorists spun elaborate narratives of hidden truth, while scientific skeptics cautioned against jumping to conclusions, recalling past false alarms and misread signals. Yet the data remained unblinking in NASA's archives, and the more it was studied, the harder it became to dismiss. For the scientific community, the priority was clear. Decode the pattern. Teams of mathematicians, linguists, and cryptographers joined forces, treating the cosmic oscillations as a kind of Rosetta Stone. Algorithms were trained to detect repeating motifs. Neural networks sifted the time series for hidden messages. Every angle was pursued in hopes of translating the deadliest whisper of the interstellar deep into human language. Yet the more effort they poured into the task, the more questions multiplied. Was the modulation constant or evolving? Did it possess a syntax, a grammar of cosmic signals, or was it an artifact of a natural phenomenon too complex for random chance yet devoid of conscious intent? Between the thrill of discovery and the edge of fear, the stakes were enormous. If the phenomenon signaled an approaching wave of high-energy particles, Earth's technological infrastructure could be at risk. Satellites, power grids, communication networks, all vulnerable to radiation storms on a scale never before imagined. Precautionary measures would have to be considered. From boosting fault tolerances to developing new shielding strategies, the discovery was no longer just academic curiosity, but a matter of practical survival for modern civilization's fragile web of technology. Yet the greatest unease stemmed from the stark reality of our powerlessness. Voyager 2 was alone, its course fixed long ago, its ancient systems humming dutifully in the dark. No spacecraft could intercept or divert the source of these cosmic storms. Humanity could only watch. Instruments pointed outward, hoping Earth's magnetic cocoon would be enough to hold. The knowledge that our planet floats in the same cosmic sea, once thought calm, now revealed as potentially hostile, was enough to make even the most rational mind shudder. Global scientific councils convened in urgent sessions over secure channels. Strategies were drafted to model possible worst-case scenarios using Voyager 2's data to refine forecasts of particle flux through the solar system. Tools once used to predict solar storms had to be expanded to account for interstellar disturbances. Agencies that had focused on Mars rovers and asteroid defense found themselves grappling with a far more daunting threat, the raw fury of the galaxy itself. In universities around the world, students marveled at how a single aging spacecraft had disrupted centuries of complacency. Research proposals flooded in. Conferences were hastily scheduled. Funding agencies scrambled to redirect resources. The event shattered the comforting illusion that space beyond the heliosphere was a tranquil expanse. Instead, it revealed a dynamic, potentially hostile frontier where human understanding was still in its infancy. Voyager 2's mission was no longer just about exploration, but had become a cosmic warning beacon. Public interest surged. Documentaries were greenlit. Podcasts multiplied. Classrooms buzzed with a mix of excitement and dread. But beneath the media spectacle, a deeper shift took root. Humanity, long preoccupied with its terrestrial divisions, was forced to confront questions of survival, unity, and responsibility on a planetary scale. If the universe could hurl such vast and unexpected threats at us, what did that mean for our hopes of venturing among the stars? Amid this global reawakening, Voyager 2 continued its lonely vigil. Its faded golden record, a relic of hopeful greetings to distant civilizations, took on an almost tragic irony in the face of the menacing signals it now intercepted. Yet, its battered systems remained operational, beaming home every terrifying revelation. There will come a day when its power runs out and its antennas fall silent. But until that final transmission, Voyager 2 stands as both explorer and sentinel, a lone ambassador charting the frontier between human knowledge and the dark unknowable vastness beyond. As Voyager 2's transmissions poured in, the global scientific community found itself galvanized in a way not seen for decades. Research centers held late-night strategy calls. International collaboration sprung up to pool expertise and computing power. Supercomputers ran endless simulations to model the strange particle bursts, seeking clues about their source, their structure, and their potential trajectory. Every possibility, however remote, was considered. Some teams examined whether the phenomenon might be tied to the galactic magnetic field, a tangled web of invisible lines that could channel high-energy particles like a cosmic highway. Others explored whether Voyager 2 had encountered a rogue shock wave from an ancient supernova, its lethal energy still roaring across parsecs long after the star itself had died. Meanwhile, theorists dived into the implications of a true technological signal, one intentionally broadcast or accidentally leaked by an advanced civilization. Could such a civilization even exist out there, silent until now, capable of harnessing energies that dwarf our wildest dreams? Or had Voyager 2 found evidence not of life, but of its ruins? An automated beacon left behind in warning, pulsing its strange, terrible message through the void. While these speculations thrilled the public imagination, Mission Control kept its focus on the practical demands of keeping the spacecraft alive. Its power reserves, already limited, required careful rationing. Engineers agonized over which instruments to keep active, knowing every watt spent was one closer to Voyager's eventual silence. The aging probe, with its outdated computer systems and failing heaters, was now humanity's only pioneer on this unexpected frontier. Any failure now could mean losing not only priceless